Good morning, everybody. In the last lecture, we discussed the conformation of fused rings, that is decalins. And we also discussed the conformations of cyclohexane ring. Now, today we will take the conformation of rings other than cyclohexane. So first we will take the cyclopropane. So this cyclopropane ring is planar in nature, right? So it has structure like this. So this ring is planar. Further, cyclobutane ring, it exists in two conformations. Sorry, one conformation, and that is not planar in nature. In the cyclobutane, the conformation is like this. So three-membered ring, and it's like this. So cyclobutane ਏਦਾਂ plane ਚ ਨਹੀਂ exist ਕਰਦੀ, it exists as this non-planar conformation. ਇਹਦਾ reason ਕੀ ਹੈ? So this conformation results in relieving of eclipsing strain. ठीक है? So ਇਸ ਕਰਕੇ ਜਿਹੜੀ ਇਹ non-planar conformation ਹੈ, ਇਹਦੇ ਚ ਕੀ ਹੁੰਦਾ ਹੈ, ਜਿਹੜੀ strain ਹੁੰਦੀ ਹੈ due to eclipsing of hydrogen atoms, that is relieved. So ਇਸ ਕਰਕੇ it exists in non-planar conformation, right? So it exists in such a way that an angle of about 35 degree is there between the planes. ਦੋ plane ਦੇ ਵਿਚਕਾਰ ਕਿੰਨਾ angle ਹੋ ਜਾਂਦਾ ਹੈ? 35 degree. Similarly, cyclopentane also have a strain in a molecule. It exists in two puckered conformations that are non-planar in nature. Two puckered conformations. The first one is envelope, and the second is half chair. So these two conformations are present for cyclopentane. So let us draw first envelope conformation. So in the envelope conformation, the structure is like this. It's like envelope, opened envelope. Okay, so this is the enveloped conformation, 1, 2, 3, 4, and 5. And the half chair conformation is like this. Then here we have this, and this is the another bond. Okay, so this is the half chair conformation of cyclopentane, right? So let us number this. 1, 2, 3, 4, and 5. So in these two conformations, cyclopentane ring exists, and the energy difference between the envelope and half chair conformation is very small, and the most stable conformation in cyclopentane is envelope conformation, and this is confirmed by X-ray analysis. So X-ray analysis showed that cyclopentane exists in envelope conformation, right? So envelope conformation exists karan da reason hai, in this conformation there is minimum eclipsing between the substituent and adjacent hydrogen atoms. ठीक है, cyclopentane ਦੇ ਜਿਹੜੇ adjacent hydrogen atom ਹੈ, ਜਦੋਂ envelope conformation ਹੁੰਦੀ ਹੈ ਉਸ ਕੇਸ ਚ eclipsing ਘਟ ਜਾਂਦੀ ਹੈ. ਠੀਕ ਹੈ, ਸੋ ਇੱਕ ਦੂਜੇ ਨੂੰ ਫੇਸ ਕੱਟ ਕਰਦੇ ਆ. Okay, so then we take the other rings, that is cycloheptane, cyclooctane, and cyclononane. So these three rings are they have smaller stability, so they are highly unstable in nature. cycloheptane वाली 7, 8 ਤੇ 9 and they all exist in non-planar conformation. ठीक है, तो सारियां ही non-planar ਹੁੰਦੀਆਂ. Moreover, ਜਿਹੜੀਆਂ cyclohexane, cycloheptane, octane ਤੇ nonane ਜਿਹੜੀਆਂ ਨੇ, they are highly unstable due to presence of torsional strain. कल मैं दस्या सी torsional strain की ਹੁੰਦੀ है. It is the repulsions between bond pair electrons. ठीक है, and also due to presence of van der Waal repulsions between the hydrogens. Repulsions between the hydrogens. So due to presence of these two type of strains in 7, 8 and 9 member ring, these rings are highly unstable and they exist in non-planar conformation to minimize these strains. Okay, so this is all about the conformation of smaller rings. So in some case, what will happen due to presence of crowding in the molecule, ठीक है, क्राउडिंग होने करके बल्कि ग्रुप प्रेजेंट होने करके की हुंदा है, जड़ियां रिंग्स प्लेनर होनियां चाहिए, they become non planar. ठीक है, so one such example is this molecule. So in this molecule what happens, so benzene ring जड़ी, it is planar in nature, but when we have this type of substitution in which tertiary butyl group, 3 tertiary butyl groups are present, सो ये की करते हैं, इन्हां दे विचकार रिपल्शंस बहुत ज्यादा होंदियां बल्कि ग्रुप्स दे विचकार. सो इस करके दिस रिंग बिकम्स नॉन प्लेनर. सो इट डेविएट फ्रॉम द प्लैनरिटी एंड लीडिंग टू द नॉन प्लेनर स्ट्रक्चर. नॉन प्लेनर स्ट्रक्चर नाल की हो जाता है, इन्हां दे विचकार जिहड़ी स्टेरिक स्ट्रेन है ड्यू टू प्रेजेंस ऑफ बल्की ग्रुप, दैट इज मिनिमाइज्ड. समझ आ गया? हाँ जी, इज इट क्लियर?
Yes, ma'am.
Similarly, this molecule is also non-planar in nature, which has 4 tertiary butyl group. Tertiary butyl group बहुत bulky ਹੁੰਦਾ, so it lifts the molecule out of plane to minimize the steric strain. ठीक है, so these are the examples. ਆਪਾਂ ਹੋਰ ਪਿੱਛੇ ਵੀ ਇੱਕ example ਕੀਤੀ ਸੀ ਜਦੋਂ ਸੀ helicines ਕੀਤੀਆਂ ਸੀ. So helicines are also the examples. Steric bulk होने करके, repulsions होने करके helicine out of plane हो जाती हैं and they adopt the helical conformation. Okay, so this is all about the steric strain due to unavoidable crowding. Now let us take the effect of conformation on reactivity. So next topic is what will be the effect of conformation on reactivity. So first we will take the examples of acyclic molecules. So let us first take the examples of acyclic molecules, how the conformations affect the reactivity. So I'm here considering the example of E2 reactions. E2 reactions पढ़े ने? What do you mean by E2 reaction? Madam Kuljit ने तो sorry, you haven't read that. MSc च कराए हुए. E2 reaction is elimination reaction. ठीक है? So this is bimolecular elimination reaction. So let us take one example. Suppose we have 2-bromobutane. So 2-bromobutane has structure like this. So if we draw skew conformation, CH3, H, H, CH3. 2-bromo है ना? So this is 2-bromobutane. Okay. ठीक है। सो एक तरीका है कि ਤੁਹਾਡਾ ਜਿਹੜਾ ब्रोमो है it is in vicinity of hydrogen of second carbon. Second possibility is, let us draw the second possibility is also by taking this first carbon configuration constant. Second possibility is methyl is facing the bromine. So this is it. Okay. So if we represent both the structures in Newman form, the Newman form is like this. So first carbon H here, CH3 here, and H here. First वाला carbon draw किया. जेड़ा back carbon है उससे bromo इत्थे है. Methyl is between two hydrogens and H is here. So this is one conformation. Let us draw for this one also. So here we will be having front carbon jada hai uda methyl on this side, H, right? And bromo is again here. Here is we are having the methyl and H. ਹੁਣ ਤੁਹਾਡੇ ਅਕੋਰਡਿੰਗ ਚੈੱਕ ਆਊਟ ਕਰੋ whether structure 1 or structure 2 ਦੋਨਾਂ ਚੋਂ ਜ਼ਿਆਦਾ ਫੇਵਰੇਬਲ ਕਿਹੜੀ ਹੈ?
फर्स्ट वाली मैम।
क्यों?
स्टेरिक इंडेक्स कट होते हैं।
Yes, that's right. In the first structure, ਹੁਣ ਦੇ ਜੇ ਆਪਾਂ ਧਿਆਨ ਨਾਲ ਦੇਖੀਏ first ਤੇ second ਨੂੰ, the difference is here. Let me highlight it with green pen. H, CH3, and here are the two bulky groups that are very close. Okay. ਹੁਣ E2 elimination होनी है, anti elimination होनी है. Means ब्रोमो जड़ा है एक साइड तो निकलेगा, H ਉਹਦੀ opposite side ਤੋਂ ਨਿਕਲੇਗਾ. ਹੁਣ ਇਹਨਾਂ ਦੋਨਾਂ cases ਚ H ਤੇ Br they are anti to each other. But the difference lies here in the second conformation, two methyl groups are gauche, whereas in case of one, the two methyl groups are exactly anti to each other. देख रहे हो ध्यान ਨਾਲ structure? हाँ जी.
Yes.
So ਇਹਦਾ ਮਤਲਬ this first structure is highly favorable and we will be getting, so let us draw the products. So in this case, the product has structure like this. C double bond C, and two methyls are exactly opposite to each other. H, right? So in this case, the product will be C double bond C. Two methyls are facing each other, and the product is here. Cis keda, trans keda?
नीचे वाला cis मैम।
Yes.
ऊपर वाला trans।
And above one is trans. And you are saying the first conformation is favorable. So ये ज़्यादा stable होएगी, and ज़्यादा stable होने करके it will eliminate the HBr rapidly, and we will exclusively get a trans product. So in this way, the conformation of molecule affects the reactivity. So that the first structure it is highly reactive क्योंकि ये ज़्यादा favorable है, and we will be getting the trans product, trans alkene as a major product. ठीक है? हाँ जी, समझ लग गया?
Yes मैम।
So इस तरह जड़ा है conformation जड़ी है, it affects the reactivity of molecule. So this reaction will mainly give a trans isomer as a product. So let us take one more example of this elimination reaction. So suppose we have 2,3-dibromobutane. So 2,3-dibromobutane. So let us draw the structure. Br सो इत्थे आपां डीब्रोमिनेशन करनी है. We want to debrominate this. So this is one form, right? The second form is, this is basically a mesoform. And the second form is in which Br here, H here, methyl here, and here we are taking this constant. कोई भी एक कार्बन तुसी constant रख सकते हो. So this is Br. ਹੁਣ ਇਹ ਦੋਨੋਂ ਦੀਆਂ ਕਨਫਰਮੇਸ਼ਨਸ ਡਰਾ ਕਰੋ ਨਿਊਮੈਨ ਜਿਸ ਤਰ੍ਹਾਂ ਮੈਂ ਅੱਗੇ ਕਰਾਈਆਂ. ਐਂਡ ਦੋਨਾਂ ਚੋਂ ਮੈਨੂੰ ਦੱਸੋ ਕਿ ਸੋ ਪ੍ਰੋਡਕਟ ਕਿਹੜੇ ਕਿਹੜੇ ਬਣਨਗੇ ਦੋਨੋਂ ਕੇਸਿਸ ਚ ਮੈਨੂੰ ਦੱਸੋ. So this is plus minus 2,3 dibromobutane. So if we draw here the Newman projection formula, first carbon jada hai H, CH3, Br here. Second carbon methyl, पिछला वाला H and Br. On elimination anti होनी है. So this Br from here and this is from here. ठीक है? So as a elimination है, this results in formation of two methyls are anti to each other. ठीक है? इतने दूसरा फॉर्मेट भी बन सकता है कि ए वाला H सॉरी ए मिथाइल इधर ले जाओ H ले जाओ जिद्दां आपां फर्स्ट वाला कीता सी. ठीक है? सो क्योंकि ਉਹਦੇ ਚ ए वाली फेवरेबल स्ट्रक्चर सी सो मैं सीधा यही लिखा. ओके, so this will give the product in which alkene has two methyl groups trans to each other. So we will be getting a product with a trans conformation. Okay, now let us take this plus minus 2,3 dibromobutane. So in this case, if we draw the Newman projection formula, so it's like this: H methyl Br, H methyl Br. Okay. ठीक है जी. So again, 2 bromo will leave, but in this case, the product will be cis. So here the product will be cis. Trans नहीं possible. Trans क्यों नहीं possible? जब अपन rotation करते हैं A methyl the round, we will be getting meso product. So this means the debromination of meso product will always gives a trans butene as a product, whereas debromination of DL isomer will give cis alkene as a product. ठीक है? तो इस केस च की है, वैसे देखा जाए तो इन्हां दोनों चों की है एवरी ट्रांजिशन स्टेट जिहड़ी इट इज लैस स्टेबल, बट इस केस च होर पॉसिबिलिटी नहीं है, इस करके की है it is transformed to cis product. Okay, ठीक है जी. चलिए आगे. So the debromination of meso will always give trans product, whereas debromination of DL pair will give cis product. तो जिहड़ी debromination है to DL pair दी, it is slow comparatively. It is slow in comparison to meso. The reason is it involves the highly unstable transition state. ठीक है? Okay. So
Yes, ma'am.
now let us take another example of acyclic systems, that is pyrolytic elimination. Pyrolytic elimination. So दोनों example elimination reactions दी हैं. ਹੁਣ ਜਿਹੜੇ pyrolytic reactions ਹੁੰਦੇ ਆ ਉਹਨਾਂ ਦੀ ਇੱਕ property है कि pyrolytic elimination ਉਦੋਂ ਹੀ ਹੋਏਗੀ when the two eliminating groups are cis to each other. Group are cis to each other. ठीक है? To each other. So otherwise they will not eliminate. So suppose we have, let us take the example of one xanthate. So this type of xanthate is there. H R2 R1, and here we have double bond S methyl, and here is R4 R3. ठीक है? So S case की है, Na eliminate होना है, and this H they will, ਜਿਹੜਾ ਹੈ O negative ਬਣਿਆ, it will take up the proton. So ਇਹ ਦੋਨੋਂ groups ਜਿਹੜੇ ਨੇ, they should be cis to each other. So this results in formation of this type of compound. So here you can say the conformation, that conformation of molecule is favored in which two eliminating groups are cis to each other, then only the pyrolytic elimination will take place. Okay. ठीक है जी. So in this case, syn elimination takes place. So O conformation ਜਿਹਦੇ ਚ ਦੋ groups ਜਿਹੜੇ ਨੇ, they are syn to each other, that is more favorable, and products are formed corresponding to that conformation. Okay. Now let us take the effect of conformation on the reactivity of cyclic compounds. So ज़्यादातर ਜਿਹੜੇ cyclic compounds ਆ ਉਹਨਾਂ ਚ ਜ਼ਿਆਦਾ examples ਜਿਹੜੀਆਂ ਨੇ, that is of cyclohexane. ठीक है? ਹੁਣ cyclohexane ਦੀ ਇੰਨੀ example ਕਿਉਂ ਹੈ? ਕਿਉਂਕਿ ਇਹ ਜਿਹੜਾ cyclohexane system ਹੈ, it widely exists in natural products. ਇਹ ਜਿਹੜਾ ਹੈ, it natural product ਜਿਵੇਂ ਕਿ steroids ਨੇ, steroids, terpenoids, carbohydrates, in all these systems cyclohexane ring system is existing. ठीक है? तो ਹੁਣ ਤੁਹਾਡੀ cyclohexane ring ਚ environment ਕਿਸ ਤਰ੍ਹਾਂ ਦੀ ਹੈ, axial ਤੇ equatorial groups ਤੇ, that will define the reactivity of molecule. ठीक है? So now let us first take the example of substitution reactions. On substitution reactions, if we are taking SN2, substitution, nucleophilic substitution bimolecular, this SN2 reaction will take place readily with the axial substituents, with axial substituent, then equatorial. ठीक है? तो O conformation ਜਿਹਦੇ ਚ leaving group axial होएगा, that conformation is favored in comparison to in which the leaving group is equatorial. So let us take the example. Suppose we have we want to do the reaction of tertiary butyl, 4 tertiary butyl cyclohexyl bromide reaction ऐदा करना है with, you can say, thiophenol. So you want to react these two molecules. So now let us take the two conformations of tertiary butyl. ਤੇ ਪਹਿਲੇ ਹੀ ਤੁਹਾਨੂੰ ਪਤਾ ਹੈ ਕਿ ਜਿਹੜਾ heavier group ਹੈ, ਮੈਂ ਕੱਲ ਕਰਾਇਆ ਸੀ, it always takes the equatorial position. ਜਦੋਂ equatorial position ਹੀ tertiary butyl group ਨੇ ਲੈਣੀ ਹੈ, it will not occupy any other. So ਹੁਣ difference ਕਰਤੇ ਰਹਿ ਗਿਆ bromine. ਇੱਕ case ਆਪਾਂ ਲੈ ਲੈਨੇ ਆ ਜਿਹਦੇ ਚ bromine axial ਹੈ, and the second case which we are taking is in which bromine is equatorial. So this is your tertiary butyl group, it adopts. ਹੁਣ ਇਹਨਾਂ ਦੋਨੋਂ conformations ਚੋਂ which will react rapidly with thiophenol. So thiophenol ਚ ਜਿਹੜਾ nucleophile ਹੈ that is S negative phenyl, and here also S negative phenyl. So out of these two, suppose this is conformation 1 and this is conformation 2. So what we found that the conformation 1, the bond cleavage of axial bromine takes place about 60 times faster than in conformation 2. ठीक है? So you can write this thing like this. The SN2 reaction of thiophenoxide ion with 4 tertiary butyl cyclohexyl bromide having an axial bromine takes place about 60 times faster than those which is having the equatorial bromine. ठीक है? ਹੁਣ ਤੁਹਾਨੂੰ ਮੈਂ ਪਹਿਲੇ ਹੀ ਦੱਸਤਾ ਸੀ ਕਿ ਜਿਹੜੇ SN2 reactions ਹੈ ਉਹਨਾਂ 'ਚ axial conformation favored ਹੁੰਦੀ ਹੈ in comparison to equatorial. So phenoxide ion ਜਿਹੜੀ ਹੈ it will attack from backside. SN2 reaction 'ਚ ਕੀ ਹੁੰਦਾ ਹੈ, ਇੱਕ bond cleave ਹੁੰਦਾ ਹੈ, ਦੂਸਰਾ form ਹੁੰਦਾ ਹੈ. So here the attack of S phenoxide ion is easy in case of conformation 1 then conformation 2 ਜਿਹਦੇ 'ਚ axial position ਤੇ bromine ਹੈ. ਠੀਕ ਹੈ? ਹੁਣ ਇਹਦਾ ਰੀਜ਼ਨ ਕੀ ਹੈ ਕਿ ਜਦੋਂ ਇਕੁਏਟੋਰੀਅਲ ਤੋਂ ਤੁਹਾਡਾ ਨਿਊਕਲੀਓਫਾਈਲ ਅਪਰੋਚ ਕਰਦਾ ਹੈ, it met with minimum steric hindrance from the neighboring hydrogens. So neighboring hydrogen ਕੋਲੋਂ ਦੀ ਜਿਹੜੀ steric hindrance ਹੁੰਦੀ ਹੈ that is minimum when nucleophile approach from equatorial position. ठीक है? Is it clear?
Yes, ma'am.
Okay. Now we will take the example of SN1 reaction. ਹੁਣ SN1 reaction जो ਤੁਹਾਨੂੰ ਪਤਾ ਹੈ it involves the formation of carbocation. So ਇਹਨਾਂ 'ਚ ਕੀ ਹੁੰਦਾ ਹੈ, there is formation of carbocation. ਹੁਣ carbocation ਜਿਹੜੀ ਹੈ it can easily relieve the you can say steric strain. So now in this case let us take the example. We want to carry out the acetolysis of cis 4 tertiary butyl CME thrice cis 4 tertiary butyl cyclohexyl tosylate. So this is your cis 4 tertiary butyl cyclohexyl tosylate. So this tosylate is basically a leaving group. ठीक है? So इस case we put it at the axial position. Okay? So this is cis conformation. So if we take the trans conformation also, तो ਤੁਹਾਨੂੰ ਪਤਾ ਹੈ CME3 ਤੇ ਹਮੇਸ਼ਾ ਹੀ ਇਸ case 'ਚ ਕੀ ਹੋਣਾ ਹੈ, equatorial. So next वाले पे these are opposite. This is in opposite. So here we have to put, if we want to put this in trans conformation, we should put it in equatorial conformation. ठीक है? ਹੁਣ ਜਦੋਂ ਅਸੀਂ ਇਹਨਾਂ ਦਾ acetolysis ਕਰਦੇ ਹਾਂ, when we treat these two with the acetate ion, the acetolysis of this cis isomer is faster in comparison to this second one. It is slower, and both of them led to the formation of carbocation. So दोनों केस च carbocation same बनती है, पर trans वाले केस it is slow, whereas in cis one it is faster. ਹੁਣ SN1 ਜਿਹੜਾ reaction है, it is sterically assisted for an axial substituent. ठीक है? जबकि equatorial substituent ਲਈ there will be no steric assistance. ठीक है? ਇਸ case again ਇਹ ਜਿਹੜਾ it will be easily cleaved, whereas from equatorial position it is very difficult to cleave it, and for this reason the acetylysis of cis isomer is faster in comparison to trans isomer, and it is almost 3.4 times faster. ठीक है? So next is the cyclic compounds जो और example है, that is of esterification and hydrolysis. हाँ जी, esterification की होंदी है? esterification की होंदी है?
एस्टर की फॉर्मेशन होनी है।
Yes, ester की formation होनी, ठीक है? So S case च भी की है, your axial and equatorial conformational isomer react at different rates due to presence of 1,3 diaxial interaction. ठीक है? So it depends upon the condition. So 1,3 diaxial interaction होने करके axial ते equatorial isomers they react differently. Most of the time, the esterification and hydrolysis occurs more readily with equatorial isomer. S case की है, it occurs more readily with equatorial isomer. So here one example is given, and that is of cholesterol acetate. So cholesterol acetate jada basically it is like this. OCOCH3 a bond the C hydrolysis करना, and here we are having methyl group. So it is having the this acetyl group equatorial. So S case ਜਿਹੜੀ ਤੁਹਾਡੀ esterification ਹੈ, sorry hydrolysis ਜਿਹਨੂੰ ਅਸੀਂ sponification ਕਹਿੰਦੇ ਹਾਂ, esterification ਦਾ reverse. So hydrolysis is faster in comparison to the axial substituent. So S case if we have acetate here, so S case axial वाले ਦਾ comparatively ਇਹਦਾ hydrolysis ਜਿਹੜਾ ਹੈ it is faster. ठीक है? Next is the again you have given the example of elimination reaction that you can see we already did in the acyclic systems. So cyclic system दियां भी almost parallel ही हैं. Next I will take the example of molecular rearrangement. सो ਤੁਸੀਂ ਇਹ ਸਾਰੀਆਂ ਐਗਜ਼ਾਮਪਲ ਚ ਇੱਕ ਚੀਜ਼ ਨੋਟਿਸ ਕਰੋ ਕਿ ਜਿਹੜੇ ਐਕਸੀਅਲ ਸਬਸਟੀਟੂਐਂਟਸ ਨੇ they react at different rate in comparison to those bearing the substituent at the equatorial position. Okay, so molecular rearrangements there are numerous examples, so I will take only one here. So let us discuss the pinacol-pinacolone rearrangement. ਤੁਸੀਂ ਕੀਤਾ ਹੋਇਆ pinacol-pinacolone rearrangement ਕੀਤਾ ਨਾ? So we will be having a diol. Diol ਹੁੰਦੀ ਹੈ ਸਾਡੇ ਕੋਲ, but in this case I am taking the cyclic diol. So suppose we have this diol. This is cis isomer. Okay, and then similarly we can draw the trans also. So trans the case ch ki hoega? So I will keep one set constant, ਦੂਜੇ ਨੂੰ reverse ਕਰ ਦਾਂਗੇ. CH3 is here, OH is here. So this is trans isomer and this one is cis. ਹੁਣ ਤੁਹਾਨੂੰ ਪਤਾ ਹੈ ਕਿ pinacol-pinacolone rearrangement ਕੀ ਹੁੰਦਾ ਹੈ? There occurs the formation of carbocation. ਜਦੋਂ H positive ਪਾਵਾਂਗੇ, this will be protonated and we will be getting a cyclohexane with positive charge here. Okay, reverse करता हूँ. So here we will be having OH here, CH3 here. And then this results in migration of this methyl group. Rearrangement का मतलब यही है कि this methyl migrate at this center and this bond is cleaved, and we will be having this ketone and dimethyl group here. Similarly, you can write for trans isomer. ਹੁਣ ਜੇ ਤੁਸੀਂ ਧਿਆਨ ਨਾਲ ਦੇਖੋ cis isomer methyl shift ਜਿਹੜੀ ਹੈ ਈਜ਼ੀ ਹੋਏਗੀ, ਐਕਸੀਅਲ ਈਜ਼ੀਲੀ ਮੂਵ ਕਰ ਸਕਦਾ, ਬਟ ਇਸ ਕੇਸ 'ਚ ਕੀ ਹੈ ਜਦੋਂ ਅਸੀਂ ਟਰਾਂਸ ਆਈਸੋਮਰ ਦੀ ਪਿਨਾਕੋਲੋਨ ਰੀਅਰੇਂਜਮੈਂਟ ਕਰਦੇ ਹਾਂ, so instead of migration of this methyl from equatorial position, there occurs, let me draw here, migration of, or you can say ring cleavage. So ਇਸ ਕੇਸ 'ਚ ਕੀ ਹੈ, we will be getting the this type of carbocation plus CH3, and here the methyl is equatorial, बहुत दूर है, so the migration easy नहीं होएगी. So इस केस की ਹੁੰਦਾ है, instead of migration of methyl ਇਹ ਜਿਹੜਾ bond है this moves here, and we will get here in this case the product is different. So the product has structure one, two, three, four, 5-member ring बन जाएगी, and here we will be having C double bond O CH3 and one methyl is here. ठीक है, so this product is formed जड़ा कि totally different है cis तो. Okay, so in this way the change in conformation affects the formation of product. Next example is again the formation of carbocation, but here we will take neighboring group participation. Neighboring group participation. So this is very important. So इस neighboring group participation वाली example च की है कि जड़ा group neighbor ते है, if it is having a lone pair, so it gives its lone pair and stabilizes the intermediate. So suppose, let us take one example. The acetolysis of, we are taking acetolysis of trans 2-iodo cyclohexyl brosylate. So it undergoes 2.7 into 10 raised power 6 times faster acetolysis then corresponding cis isomer. ਹੁਣ ਇਹਦਾ ਕੀ ਰੀਜ਼ਨ ਹੈ ਇੰਨਾ ਜ਼ਿਆਦਾ ਰੇਟ ਇਨਹਾਂਸ ਹੋ ਗਿਆ? So the reason is neighboring group participation. So this is your compound trans isomer ਆਪਾਂ ਪਹਿਲੇ ਬਣਾਉਂਦੇ ਆ. So this is O brosylate, and here we are having the iodo group. This is trans isomer. So cis isomer the case की है, your brosylate will be equatorial and iodo is axial. So इस केस की ਹੁੰਦਾ है, this brosylate easily leave from the axial position, ते iodine को lone pair ਹੁੰਦਾ है, it gives its lone pair, mean it is basically assisting the iodide is assisting the removal of brosylate, and it results in formation of this type of intermediate which is highly stable. And when acetic acid comes, so this acetic acid again attacks from the axial position, okay, and we will be getting O acetate. But jadki S case when we take cis isomer, no such assistance is present. Brosylate equatorial होने करके जड़ा iodide है, it cannot approach the this end, ठीक है? Iodide इस end नु approach नहीं कर पाता. So इस करके its rate of acetolysis is very slow. ठीक है, बैक साइड तो आयोडाइड अटैक नहीं कर सकता, उन्हें फ्रंट साइड तो ही अटैक करना है। ਤੇ फ्रंट साइड ਤੇ ਕੀ ਬੈਠਾ ਹੋਇਆ ब्रोसिलेट ਜਿਹੜਾ कि वेरी बल्की ग्रुप है। ओके, so this is the example of neighboring group participation. Next is the oxidation. So some of the oxidation reactions are also dependent upon the nature of conformer present, ਉਹਦੇ ਤੇ ਹੀ reactivity ਹੈ ਜਿਹੜੀ it depends. So let us take the example. So when we want to oxidize both cis and trans isomer of tertiary butyl hexanone. So this is trans isomer, and let us take the another one, cis isomer. Cis the case OH like this. This is cis isomer. ਹੁਣ ਜਦੋਂ ਅਸੀਂ ਆਕਸੀਡੇਸ਼ਨ ਕਰਦੇ ਹਾਂ ਨਾ ਦੋਨਾਂ ਦੀ, the oxidation of trans with chromium trioxide and oxidation of this cis with chromium trioxide, they both give the same ketone. ਦੋਨਾਂ ਦੇ ਕੇਸ ਚ ketone same ਬਣਨੀ ਹੈ, but the difference lies in fact that trans isomer undergo oxidation slowly in comparison to cis isomer. It has faster rate. ठीक है, ਹੁਣ ਇਸ ਕੇਸ ਚ ਡਿਫਰੈਂਸ ਕਿੱਥੇ ਹੈ ਕਿ ਜਿਹੜਾ ਤੁਹਾਡਾ OH ਹੈ ਇਟ ਇਜ਼ ਐਕਸੀਅਲ in case of cis, ਇਸ ਕਰਕੇ ਜਿਹੜੀਆਂ ਆਕਸੀਡੇਸ਼ਨ ਨਾਲ ਜਦੋਂ ਇਹ ਐਕਸੀਅਲ OH ਰਿਮੂਵ ਹੋਏਗਾ, ਓਕੇ, ਸੋ ਉਹਦੇ ਨਾਲ ਕੀ ਹੋਏਗਾ, there is relief of 1,3 diaxial interaction between the beta hydrogens. ਸੋ ਇਸ ਕਰਕੇ ਜਿਹੜਾ ਤੁਹਾਡਾ cis isomer ਹੈ it reacts 3 times faster than the trans isomer. ठीक है, so this is all about the examples of effect of conformations on reactivity. ठीक है, so I will stop here.